In this question, we're gonna see what we can say about this function sine of 1 over x times 1 over x between 0 and 1. Okay, clearly we see that we have an issue on 0. We don't have problem on 1. So this is a improper integral of the second kind. Okay, so sometimes we can change the issue from the second kind to the first kind and we can make it easier. Okay, so we see that we can, first of all, we can't find a primitive. It's not easy. At least for me, I don't see a primitive of this one, and I don't know one. Okay, so what they can do is I can change the variable here by letting u is 1 over x. In this case, I have du is minus dx over x squared, and therefore dx is minus minus u squared du is it's dx. Okay, because 1 over x is u squared. I can change, it's 1 over u, sorry. It's minus 1 over u squared du, because here 1 over x is u. Okay, so let me write it one more time. So it's minus 1 over u squared du. That's giving me dx. Okay, so 1x here, we expect that this is we get to 0 from the right. Therefore here we get to u. 1x goes to 0 from the right. U is going to be infinity. So we're going to have 2 infinity. So 1x is 1, u is 1. So here I have sine of u. So 1 over x is just u, and dx is minus du times 1 over u squared. So I'm going to put here u squared. Therefore my integral is going to be minus 2 infinity 1 sine of u over u du. But this minus, I can flip this integral here. So it becomes between 1 and infinity sine of u over u du. Okay, and still with this one I can't conclude. Okay, I can't conclude. I can use something. I need to do more work to find this value. So we can say that we can do some integration by part here. Okay, to get some power here, so we can use the comparison test. That's the trick that we use all the time with the sine and cosine functions. Okay, so if we let u prime is sine of u, that means u is minus cosine u, and v is 1 over u, that means v prime is minus 1 over u squared. Don't confuse this u with this one. Okay, so here I get, but before this I should have done something before doing this. I need to write this one as to the limit as x goes to infinity between 1 and x sine of u over u du. Okay, now I can apply the integration by part here before I take the limit. So this is a critical operation before we take the limit. Okay, so now what we have is we have u. So if u prime uv is going to be minus cosine of u over u between 1 and x minus plus with 3 minuses, so it's going to be minus between 1 and x of, in this case, it's going to be cosine of u over u squared du. Now I know that the cosine, let me do one more step. So now I have minus cosine x over x plus 1 cosine 1, okay, over 1, which is 1, okay. And the next one is going to be minus 1 over x cosine of u over u squared du. Here the limit of sine x over x when x goes to infinity is 0. So I'll be left with cosine 1 cosine of 2. 2 cosine of 1, sorry, because I need to have these two, plus 2 limit as x goes to infinity of this one here. 1, let's put this minus cosine of u over u squared du. Okay, but this one here, I know it's convergent, okay, because I can use the cosine, I can use the comparison test. Cosine of u over u squared is less than 1 over u squared. So here, if I integrate between 1 and x, okay, so I can have, so minus 1 over x, minus 1 over u between 1 and x, okay? So this one here is less than the limit. This limit here is going to be between the limit of x going to infinity between 1 and minus 1 over x. And it's 1. Therefore, this is bounded by 1. Okay? So therefore, this whole integral is less than 2 cosine of 1 plus 1. And that means it's finite. Okay? This proves that this integral is convergent. Okay? So we had to transform this one from a improper integral of the second kind to a improper integral of the first kind because of this limit here to infinity. Okay? So it's less than this value. It's 2. It should have 2 because of these 2 that I keep missing. Anyways, you get the idea. So this proves that my integral here is convergent, and this ends our video.